Let me recall some of the topics that were already dealt in electronic circuits 1. I initially told that whenever you are processing a radio frequency application, its equivalent model should be represented in the pi model. So let me recall the concept of pi model and then I will begin my discussion with a single tune amplifier. Let me consider that I am going to use a transistor of an NPN type having three different terminals taken as an base, a collector and an emitter terminal. Make a remember that apart from three terminal, whenever you want to draw an equivalent model in the form of pi model, there will be one more terminal represented as B prime, where B prime is named as a virtual ground base. And if a resistance is being connected between a base and a B prime terminal, that particular resistance is named as RBB prime, where RBB prime represents a base spreading resistance. Similarly, if a resistor is being connected between a collector and a virtual base, then such a resistor will be represented as either RB prime C or it will be represented as RCB prime. Similarly, the resistance that is connected between RB prime E, that is the base terminal of the virtual ground, and the emitter terminal will be taken as RB prime E. Now, this is a basic consideration whenever you are going for an equivalent model that is represented in the form of pi model. Now, if I draw the same diagram, let me consider that I am having a base that is connected to a base terminal of a virtual ground. If suppose a resistance is being connected in between these two, it will be taken as a base spreading resistance, and if a resistance is being connected between a B prime and an emitter terminal, it will be taken as RB prime E. And the capacitance, if it is available at an input side between B prime and E, will be taken as CB prime C. So this portion will be the input circuit representation of a pi model. And if I consider the output representation will be having a current that is taken as GM into VB prime E. The reason why the current is represented as GM into VB prime E is, we know that from Ohm's law V is equal to IR. So the current can be represented as V by R. Reciprocal of resistance will be taken as a transconductance that is multiplied with V. This V represents the input voltage, that is the base emitter voltage. Hence it is being represented like this. And if I consider the output side resistance, if this is my collector terminal, the resistance that will be associated will be RCE, and this will be the output representation of the circuit. Now what I am going to do is, I am going to take this equivalent pi model circuit for an NPN transistor, and I am going to do an analysis related to single tune amplifier of my circuit. So this will be my case. Now what I am supposed to do is, I am going to construct a circuit of single tune amplifiers. For constructing a circuit of single tune amplifiers, let me take an NPN transistor that follows common emitter configuration. Since it is a common emitter configuration, emitter terminal will be connected to the ground. Now how I am going to connect my circuit is, if I need to apply a biasing for this transistors, I am going to apply biasing through two resistors taken as R1 and R2. And if I am going to use a resistor at an emitter side, it will be taken as Re. The reason why emitter resistor is being added is to avoid the transistor Q point to vary against the temperature variations. And I am going to use a capacitor named as a bypass capacitor taken as CE. The purpose of a bypass capacitor is to short all AC noises that is being available in the circuit. And in the collector terminal, since it is a common emitter configuration, the output is going to be observed at the collector terminal. Now at the collector terminal, since it is a tuned amplifier, I am going to connect a tuned amplifier to this portion, which means at the collector terminal there will be a tank circuit in the form of RLC that will be connected to an external voltage taken as VCC. So C will be the representation for a capacitance L and R. Now after this I am going to connect an input signal and it will be connected through a coupling capacitor taken as CC1, and it will be connected to an input voltage that is in the form of a sinusoidal voltage, and my output terminal will be observed across a collector, and this will be connected with a coupling capacitor and further connected to a load resistor taken as RL. So this will be my construction portion of a single tune amplifier.